Welcome to today's lesson. I'm Siamasaka Kiriam. So I'm going to take you through a lesson in physics, particularly we'll look at speed time graph. So we go straight into the lesson for today. Well, when we say a speed time graph, we are actually looking at a graph where the y-axis is actually speed, while the x-axis is actually time. So a speed time graph. So merely the first thing is that you write the heading of the type of graph. So in our case here, we are looking at a speed time graph. So we said the y-axis, this should be straight actually. So this one here, we said it is speed. And then you have to write the units, and the speed or velocity is actually measured in meters per second. And the other side, we have to write that actually here it is time, and in units, which are seconds. And for example, if we have actually an object which is moving and starting from rest, meaning that it's starting from 0, so it will move, assume this is straight, from this point to the point A, and then it moves with constant speed to a point B, and it decelerates uniformly to point C. So you can actually find the time it is taking, which is time 1, when this object was actually accelerating. And you can also determine the time T2 when this object between T1 and T2, when the object had actually constant speed. And you can also find the time T3 when the object was actually from T2 to T3 when it was actually uniformly decelerating. And so we need first of all to describe at every stage what is actually happening. We will start with from 0 to A, this point here. I will call this point T with capital. From this point T here up to A, what is actually happening to this object when it's moving. Well, this object between T to A, actually it has uniform acceleration, uniform. Uniform acceleration. So the acceleration between point T to A, actually the object here has uniform accelerating. What it means that it is moving from actually with the lower velocity to a velocity which is high. So that is acceleration. And so between A and B. So actually the object there has constant speed. In our case, we are saying actually constant velocity. So the velocity here is actually constant between A and B. And between B and C, between B and C, so from B to C, actually, the object is moving with uniform deceleration. Say, what it means that the object is moving from a higher velocity to a lower velocity. In our case here, it is moving from this velocity, which is actually V1 there, to actually some velocity here, which is actually up to 0. So this is how actually you can actually describe the motion of an object on a speed time graph. Now we will look at how, again, we can calculate distance on a speed time graph. Calculating distance on a speed time graph. Well, the general actually concept here, when you have a speed time graph like the one we have here, actually you can calculate the area under the curve. For example, the area under the curve, I can say A1 is the area under this curve here from T to A, and I can say this is the area B1, which is the area of this rectangle from A to B, and T1 to T2. And I can call this is the area also for a triangle. So on a speed time graph, actually, for you to calculate the distance, you need to find the area under the curve. Find area under the curve. The area under the graph to give you actually the distance which is covered. For example, the distance from T to A, if you want to find the distance from T to A, it means that we need to find this area under the curve, which we have denoted by A1. And so we can say the distance 1, which is equal to the area under the curve, which is noted by 1, would be equal to the area of the triangle, which is 2 multiplied by the base. Our base here is the distance between T to T1. Okay, so T to T1, you multiply it with the distance, which is the height, which is up to V1. And so the distance or your height would be actually V1. In other words, we are saying it is half multiplied by the base of the triangle multiplied by the height. This gives you actually the distance, which is equal to the area under the curve 1. So it means that once you calculate the area for the triangle, okay, A1, it means that you have found actually the distance which has been covered from T to A. Similarly, for the distance covered from actually A to B, you merely get the area of the rectangle. So we can say that distance 2, which is equal to area B1, which is equal to L multiplied by B, which is the area of the rectangle that is from actually A to B, T1 to T2, and this height actually, which is T1 to A. So you merely find the area of the rectangle. Okay, this is where the speed was constant. Then you can also find area distance 3, which is equal to area under the curve, which is actually C1, by calculating the area of the triangle, which is half multiplied by base times height. This is for the time when the object was decelerating. So basically, this is the concept which learners should know, which is actually very basic on how to calculate the distance covered from one point to another using a speed time graph. And so we'll go straight into a question and we see how we can solve this question. We have a plane which accelerates uniformly from rest for 40 seconds with the actually uniform acceleration of 5 meters per square seconds. It then travels at a constant speed for 3 minutes before slowing down with uniform deceleration to come to rest in a further 25 seconds. So the first equation is convert the 3 minutes in 2 seconds. So you ensure that when you have a question like that, you convert the units to actually to be the same. In this case, we will convert 3 minutes into actually seconds. So number A, we are actually converting minutes to seconds. And so we know that 1 minute is equal to 60 seconds. So we have been told that we have 3 minutes. Which should give us x seconds. And so we can cross multiply and say x multiplied by 1 will give us 3 multiplied by 60. And we can say x is equal to 3 multiplied by 60 divided by 1, which actually gives us 180 seconds. 180 seconds. So we have actually converted these minutes to seconds. Second part of the equation is asking us to draw a speed time graph for the whole journey. So we are taught that it's a speed time graph. So the first thing we write is we are drawing a speed time graph. So we write the heading. What we are drawing is the speed time graph, meaning that in the y-axis, we are going to have speed. So you label speed, and this should be in meters per second. And you label the x-axis that this should be time in seconds. And you have been told that actually this object comes from rest, meaning that it's coming from 0. And so it was moving with the uniform acceleration. So this is straight, and it covered actually 40 seconds. So we do not know from there it moved with constant actually speed for 3 minutes, which we got to be actually 180. So our time there would be 40 plus 180, which gives us actually 220. And further, the object actually decelerates uniformly to a point to come to rest. And it took 25 seconds. So you can add 25 to 220, which gives us 2:45 seconds. But we don't know this final velocity. And so we can find this velocity here by looking at this actually acceleration, which is uniform acceleration. The object moved from 0 to this point here when it covered actually 40 seconds. And we can use our basic equation, which we know that acceleration is equal to final velocity minus the initial velocity over time. And we are given that actually acceleration is 5 meters per square seconds, which is equal to final velocity we are looking for. And this object is actually moving from rest, which means initial velocity is 0, and then divided by the time it took for it to accelerate from rest to the point when it covered 40 seconds. So our time is 40 seconds. So we can merely make V the subject of the formula. So V will be equal to 5 meters per square seconds multiplied by 40 seconds. 1 second here cancels that second, which gives us actually 200 meters per second is our final velocity. So we can now say our velocity here is actually 200. Okay, and so meaning that now we have fully drawn our speed time graph. The second part of the equation we are asked to find is to calculate the distance the plane covered in the first 40 seconds. So first 40 seconds, it means that we need to calculate the area under the curve, which is this area here. We can call this area A. So, and we can call this distance as distance 1 is equal to the area under the curve, which is equal to half multiplied by the base multiplied by the height, which is half. And so our base here, which is this distance from 0 to 40 for this triangle. So we have multiplied by 40 seconds, and our height, as we calculated it, it is actually 200 meters per second. This second will cancel that second, and we can say 2 here, 1, and 2 into 40, it is actually 20. And if you multiplied 20 multiplied by 200, it gives us actually 4,000 meters. So we have merely calculated the area under the curve, and yet it has given us actually the distance covered in 40 seconds. Second part of the question is to calculate the distance covered by the plane when it had constant speed. So from our graph here, the constant speed, when the speed was not changing, it is from this point here to that point there. So from this point there to that point, it was actually constant speed. And we know it covered that one in 3 minutes, which is equal to 180 seconds. And so if you look at this shape here we have, it is actually a rectangle. So we need to calculate the area which we have called B, the area of the rectangle. It will give us actually the speed covered from this point here up to that point. And so we will say the distance during constant speed will be equal to, which we can call distance 2, which we said it is actually B, because it's equal to the area of B, which is equal to the area of a rectangle. We can multiply the length multiplied by the height. And the length here is the distance from 40 seconds to 220. So if we subtract 220 minus 40, it gives us 180. So our length is 180 seconds multiplied by our height, which is 200 meters per second. So this second and that second can cancel. It gives us actually 180 multiplied by 200, which is 36,000 meters as our distance number 2, when the object was moving with the constant velocity. Then the other question is calculate the distance the plane covered while decelerating. So while decelerating, it will be from this point there up to when it comes to rest. So I'm going to calculate this area here, which we have called C, for the triangle. And so we'll say distance during uniform relation. Would be equal to the area under the triangle. Be equal to the area under AC triangle, which is marked by C. So we can call this one as distance 3. So distance 3 equal to the area under the curve, which is C, which is the area of a triangle, half multiplied by the breadth multiplied by the height, which gives us half. And we know that after the constant speed, it took actually 25 minutes. 25 minutes, 7 seconds. So our breath is 25 seconds multiplied by our height, which is 200 meters per second. So we can actually cancel out the seconds there and divide 2 here, 1, 2 there, 100. And therefore our distance would be 2,500 meters. So this is how actually you can calculate the distance on a speed time graph, and how you can also calculate the acceleration. Okay, so if we are to calculate now the acceleration from A, from rest to the time when it covers actually 40 seconds. So acceleration is equal to final velocity minus the initial velocity over time, which is equal to, we are aware our final velocity is actually 200 meters per second minus 0 meters per second, since it was starting from rest, divided by 40 seconds, which gives us actually to give us 200 divided by 40, which gives us 5 meters per square seconds. Then the acceleration during constant speed to be actual acceleration is equal to final velocity minus initial velocity over time, which is equal to, our final velocity is actually 200 meters per second, and our initial velocity is 200 meters per second. And this period it covered actually 180 seconds. This gives us actually 0 meters per square seconds. Actually, the deceleration when the object was actually decelerating. So we can get it by also saying acceleration is equal to final velocity minus initial velocity over time. And from our graph, our deceleration actually, our final velocity is 0 here, and our initial velocity is actually 200. So final velocity is 0 minus 200 meters per second divided by the time during deceleration was 25 seconds. So divided by 25 seconds, which gives us negative 200 divided by 25, it gives us actually 8. Negative 8 meters per square seconds. This is negative because actually the initial velocity is greater than the final velocity. And so this is actually how you can develop concepts, basic concepts on a speed time graph. So I thank you very much. Those who want one-on-one lesson, you can contact me on my WhatsApp number, which is actually plus 2609774199949. You get more concepts and you fully understand physics and be able to pass your examinations. So this is actually the WhatsApp number. You can contact me if you want online one-on-one lessons. I thank you.